How does this equation differ from the ones in the first tutorial? Consider the title of this tutorial. That one you can answer for yourself, right? Has to do with the bases, right? Bases are not related. Right? 5 and 8 aren't related. They're not powers of the same base, whole number powers. How does this equation differ from the exponential equations in the first two problems in this tutorial? How does this one differ from this one and the other one? X is on both sides. That's a good observation. There's a lot of ways it differs. Obviously 5, 8 are different numbers. This has an x plus 3 instead of a times. The biggest difference, the most significant difference is the fact that x is on both sides, right? Variable on both sides. So that's going to require a little bit of thinking once you start to access the variable. So you could probably start the same way. If the variable is in the exponent, the way you can get at it is by taking the logarithm of both sides. So I'm going to start by writing this. I'm going to write it over here so I have lots of room. 5 to the 2x equals 8 to the x plus 3. The way we're getting at this thing is we're doing the base 10 logarithm of each side. And then we're going to try to start to simplify using the power rule. If you want, you can just put the x down here. You could make it x times log 5 squared if you want. You could do that if you want, right? You could actually just make it x times log of 25 if you want. But probably most people are going to want to bring down the entire thing here like that. And then this is x plus 3 times log of 8. Is that okay to write it like that? Yeah, you got to do this because up here it's assumed there's sort of implied brackets with the notation, but you got to put that in brackets there. This was an exponential equation. You have now turned it into a linear equation because it's just numbers multiplied. Really, this is like a grade 9 equation that you would have solved. The only difference is that these weird numbers are in here. Those are just numbers. They're just decimals or calculator notes. You just treat them as some kind of decimal number, right? I wouldn't write the decimal now because it makes it look a lot more strange. But why is this? This might be the step that you got to that you said, well, I don't know what to do here now. What could I do here? Give me some suggestions. Yeah, you can multiply this out. If you're ever stuck on this, think about what would you have done if this was just a grade 9 equation. If this was, just think of, if these were whole numbers here, think about what you would have done. If you had x times a couple of different, like 2x times 3 or something like that equals x plus 3 times 5. If you had an equation like that, think about how you'd start to simplify it. You'd multiply this out, right? And you'd multiply those two numbers, 2 times 3, right? You can't multiply 2 times log 5 nicely. We can leave that, but we can certainly expand this side of it. This is x plus 3 times a number, so write it out. It's x, I guess we'll stick to the same color, x times log 8 plus 3 times log 8. It's 2 terms there, right? And here we have, if you want to write it like this, you can write it as x times 2 log 5, if that makes you happier. 2 log 5 times x. It doesn't matter. Whatever you're more comfortable with. Okay? The normal way people write it is this, but it doesn't matter. As long as you realize it's x times those other two things. What's the problem here? What we can't. How is this different than up here? What did we do once we started? After we used our power rule, what was our next? We tried to isolate x. X was there. What's the problem in this one? Understanding what the problem is, you need to do that before you understand how to fix that problem. It's still on both sides here. Think about what you would have done in grade 9. If you had 2x equals 3x, or let's say 5x, plus 7. How would you have solved that in grade 9? Yeah, one way people think about it is they gather all the x's on one side and make it 2x minus 5x. Or 5x minus 2x on the other side. Can you nicely do 2 minus 5 in your head? Yeah, you can, right? It's negative 3x. What if this was 2 minus 3.7? Maybe you can do that in your head? If you can't, let's pretend you're too lazy to do that and you say, I don't know what that is. I'm just going to write 2 minus 3.7, whatever that is. It's that times x. Does that make sense? You could just say, I don't care, whatever it is, 2 minus 3.7, I'll write it like that. You could do that and then say, to get x by itself, because you've just changed it where x was in 2 places to x in 1 place. If I showed this to somebody in grade 9 or 10, they would say, oh, I see what someone did. What did they do? They use an F word. Not the F word you might be thinking about, but they factored out the x. Okay, they factored out the x. You factored out the x. If you factor out the x, it allows you to take it from 2 places to 1. That is the key step, okay? You know, like they have for sports, they have the TSN turning point and all that? That is the TSN turning point of this question. If you can't do that, then that's the one thing. That's the one thing here, because I guess it's not exactly, well, I guess it is, right? If someone's doing a question like, yeah, I'm doing well, I know how to do it. Oh, and then if they can't do that, then it's hopeless, right? That's the point, that this is where people get stuck because they're not sure what to do there. Actually, they might even know to gather it on one side, right? 2x log 5 minus x log 8 equals 3 log 8. So then comes what do we do now, right? Even though these are strange, weird-looking numbers, we can apply the same principle as we looked at here. What can we do? I wonder if I could do this. Let's try this. I don't have any space, so what I'm going to do is, everybody okay if I do that? My handwriting's already a mess, so if I just squish it up a bit, it's still a mess. Doesn't matter. So what do we do with this now, right? It's in 2 places. How do we get it to be in only 1 place? Down here, remember what you did? It made sense here because you could see these numbers, right? Well, I don't know how to do 2 minus 3.7, so I'm just going to write it in brackets. I don't know how to do 2 log 5 minus log 8 in my head, so I'm going to just write that. 2 log 5 minus log 8. I'm just going to do that because I do not know how to do that in my head, but whatever that is, that's how many x's I have. You're factoring out the x, but whatever way you want to look at it and understand, right? Like if you had root 3x minus 5x, you can't do that nicely in your head, so you can just write, well, whatever root 3 minus 5 is, that's how many x's I have. Whatever numbers are there, you could just write them, that's how many x's, right? You're factoring it out. You're factoring it out, but if you prefer to think of it as just subtracting the way you did before, that's fine, right? You have 2 log 5 minus log 8. Whatever those numbers are, that's how many x's you have. Then, now that you've made the TSN turning point, then you can isolate x, right? How do you isolate x here? Yeah, just like what you would have done over here, right? If you're ever not sure, resort to thinking about what you would have done for a grade 9 equation, right? Go back to first principles and think about, if this was numbers I knew how to work with here, right? Like over here, even if, 2 minus 5 times x equals 7, nice x. Divide by 2 minus 5, right? 7 over 2 minus 5. That's what you would have done. You would divide. So divide here, right? Divide by this long expression. And that gives you what you're looking for, right? 2 log 5 minus log 8. 2 log 5 minus log 8. You don't have to show that step. I mean, we're past grade. It's not grade 9 anymore. You don't have to write, you don't have to say, I'm dividing both sides. Look, see, I'm dividing. You can just write the result of that division. What would the result be? X is equal to 3 log 8 divided by, yeah, that other ugly expression, right? Minus log 8. You don't have to write that step that I have in red there, right? It is exactly equal to whatever that expression is. I think actually there's 2 TSN turning points, because for some people, the putting it on the calculator, which is usually the easiest step, for this expression might not be the easiest step. Try putting that on your calculator and making sure that you get an answer that's reasonable. Check the answer in the original equation. Sorry, the original equation up here, to make sure your answer works. And then try solving the one after that, problem number 4. Okay? I'm going to compress this again to fit it in. Okay, so we're going to pause this.